In this question, we're going to determine an expression for the sine of 5 theta using only the angle theta in the final expression. In other words, when you see sine of 5 theta written like that, the angle is 5 theta. Well, we only want the angle theta to be there. So this question is going to involve a lot of algebra, distributing and collecting like terms, and so it'll require us to be pretty organized. And there's different paths to the correct answer, and the correct answers might not all look exactly the same, and that's okay. One way of writing the sine of 5 theta is to call it the sine of 3 theta plus 2 theta, and then that enables us to use our compound angle formula. Since the sine of a plus b is sine a cos b plus cos a sine b, therefore the sine of 3 theta plus 2 theta is sine 3 theta cos 2 theta plus cos 3 theta sine 2 theta. We're going to call this equation 1, and we're going to eventually come back to it. Our strategy now is going to be to break up the sine of 3 theta into an expression only involving theta, and to break up the cos of 3 theta into an expression only involving theta. Now, we don't have to work too hard on the cos of 2 theta because we actually have 3 formulas for that. We can call it cos squared theta minus sine squared theta, or we can call it 1 minus 2 sine squared theta, or we can call it 2 sine squared theta, 2 cos squared theta minus 1. So we have options here, so we're not going to have to work too hard at that. And similarly, we're not going to have to work hard at all here because we know that the sine of 2 theta is 2 sine theta cos theta. So basically, in the next couple of slides, we're going to be doing some work to get sine 3 theta expressed as an expression only involving theta. And we're also going to do some work to get cos 3 theta expressed the same way. And then we're going to be able to plug all those expressions into here, multiply, distribute, collect like terms, etc. So let's start by getting sine 3 theta expressed in terms of only theta. Well, let's use compound angle formulas again. The sine of 3 theta is the sine of 2 theta plus theta, because that's what 3 theta equals. And we know the sine of a plus b is sine a cos b plus cos a sine b, so the sine of 2 theta plus theta is sine 2 theta cos theta plus cos 2 theta sine theta. Now we just have to plug in the expression for sine 2 theta and one of our 3 options for cos 2 theta. It really doesn't matter which one we use. So like it says here, sine 2 theta is 2 sine theta cos theta. Let's use the formula that cos 2 theta is equal to 1 minus 2 sine squared theta. But like I said a minute ago, you can use either of the other two as well, and you'll still ultimately get a valid answer. So we plug those in. We see that the sine of 2 theta is 2 sine theta cos theta. We see that the cos of 2 theta is 1 minus 2 sine squared theta. And then what we do is distribute. This thing distributes here, and we multiply these two terms together. And when we do all that, we get this long expression for the sine of 3 theta. Now, what's the point of that? Well, every angle, everything that we're taking the sine or cos of, is just theta. There's no 2 thetas, 3 thetas, 5 thetas, or anything. So we're getting closer to our goal. Okay, so we're going to call that equation 2. Okay, we have equation 1 written there. We're going to call this equation 2, and we're going to remember it. Now, we've figured out an expression for this involving only theta. Let's figure out an expression for this involving only theta. Okay, well, we can say that the cos of 3 theta equals cos 2 theta plus theta. We know that the cos of a plus b is cos a cos b minus sine a sine b. So the cos of 2 theta plus theta is cos 2 theta cos theta minus sine 2 theta sine theta. Well, the sine of 2 theta is 2 sine theta cos theta. So we're going to plug that in and obviously plug it in for that. So it'll get multiplied by sine theta. And the cos of 2 theta is whatever we want it to be out of these 3 options, cos squared theta minus sine squared theta, or 1 minus 2 sine squared theta, or 2 cos squared theta minus 1. And it really is up to us which one we choose it to be. Okay? So in this question, like it says here, we'll sub in, obviously, 2 sine theta cos theta for sine 2 theta. That's our only option. We have options, though, as I expressed earlier, for cos 2 theta, so let's call it 2 cos squared theta minus 1. We could have called it either of the other ones as well. So now what we've done is for cos 2 theta, we've subbed in 2 cos squared theta minus 1. For sine 2 theta, we've subbed in 2 sine theta cos theta. And now we distribute. Okay. And we multiply these two factors together, and we get this long expression here. And we're going to call that equation 3. Okay. So now we've got an expression for sine 3 theta involving only theta, and an expression for cos 3 theta involving only theta. We use any one of our double angle formulas to express cos 2 theta in terms of only theta, and we use our double angle formula for sine 2 theta to express it in terms of only theta. And we go. Now, it says here are 3 numbered expressions. We actually have 5 numbered expressions, 5 numbered equations. This is equation 1. This is kind of like the master equation. We're going to sub this expression in for sine 3 theta in equation 1. We're going to sub this expression in for cos 3 theta in equation 1. We're going to sub in this expression for sine 2 theta in equation 1. And we're going to sub in this expression for cos 2 theta in equation 1. And of course here, we could have also subbed in either of these. Our final answer wouldn't look identical, but it would still be a correct final answer. Okay, so now we are going to do some distributing. When you plug in for sine 3 theta, the expression we had from equation 2, when you plug in for cos 3 theta, the expression we had from equation 3, when you sub in for cos 2 theta, a known double angle formula, and for sine 2 theta, another known double angle formula, and distribute, you get this long expression here. Now, you can simplify by collecting like terms. If you collect like terms there, you end up with this expression here. There are no like terms to be collected. But every single angle is theta. Sine of theta to the exponent 5. Sine of theta, quantity cubed. Sine of theta, quantity squared. Sine of theta. Cos of theta, quantity to the 4. Sine of theta, quantity cubed. Sine of theta and cos of theta, quantity squared. We've answered the question the way it asked us to, and we're happy. Okay? And we'll get to these other slides in a later video.